Earth is once again standing in the path of something vast, invisible, and electric. A 700,000 kilometer per hour stream of charged particles, born from a rare transequatorial coronal hole, has erupted from the sun's surface, stretching across hemispheres like a magnetic highway aimed directly at us. At the same time, far beyond the orbit of Mercury, an interstellar traveler named 3 Sunta Atlas slips silently behind the sun. It vanishes from our instruments without warning, as though swallowed by the star itself. And, for a brief moment, the entire solar system holds its breath. You're watching Lumora, where science meets mystery. Tonight, we explore a moment when two extraordinary cosmic events collided, raising questions about whether the sun and this wandering interstellar object could be linked in ways we still don't understand. To astrophysicists, what happened in October 2025 was more than coincidence. They call it a perfect coupling event, a rare alignment where the sun's magnetic gateway opens fully, letting streams of plasma surge toward Earth with almost no resistance. When that happens, our planet's magnetic shield must face the storm head-on. This is not the first solar storm humanity has seen, but the timing was uncanny. As the coronal hole widened, geomagnetic activity intensified. Satellites began detecting elevated proton counts, auroral belts expanded, and power grids prepared for impact. Then, at almost the same moment, seismographs around the Pacific Rim lit up with a sudden spike of magnitude 7 earthquakes. Coincidence? Maybe. But for those watching both the sky and the ground, it was hard not to feel a pattern emerging. A whisper of cosmic rhythm linking solar storms, seismic waves, and the quiet disappearance of a visitor from another star. Official reports, of course, dismissed any connection. The NOAA's Space Weather Prediction Center treated the solar storm as a routine high-speed stream. The USGS called the earthquake cluster statistically ordinary, yet behind the public calm, researchers compared magnetic indices and solar wind velocities, searching for patterns in the data. What they found wasn't proof, but it was strange. The interplanetary magnetic field that week was tilted sharply southward, holding steady near to 12 nanotesla. That's not unusual in itself, but it is the exact orientation most likely to merge with Earth's north-pointing magnetic field, allowing solar energy to pour into the magnetosphere with maximum efficiency. It's like two electrical circuits clicking perfectly together. When that happens, auroras become the visible scars of a deeper exchange. Curtains of light rippled over Michigan and Maine that night, their glow marking where the solar wind had fused with our planet's defenses. To the untrained eye, it was just beauty. To scientists, it was the signature of an open door between Earth and Sun. And behind that door, beyond the solar disk, 3 Atlas drifted unseen. The third interstellar object ever confirmed by humankind, its chemistry, orbit, and activity, all unlike anything from our solar system. A traveler from another star now caught in the gravitational fire of ours. When it vanished, it left behind more than a mystery. It left a question that still hangs in the vacuum of space. What happens when something not born of the sun meets its energy head-on? A coronal hole is not an actual hole in the sun's surface, it's a gateway. A region where the sun's magnetic field loosens its grip, allowing plasma to escape freely into space. Most of the sun's surface is locked in loops of magnetic tension, twisting and trapping superheated gas in brilliant arcs of light. But inside a coronal hole, those magnetic lines stretch outward, open, unbound, and wild. It's like the sun exhaling. Through these gaps, charged particles are released in torrents. The escaping plasma forms a stream we call the solar wind. Depending on the sun's activity, this wind can race through the inner solar system at speeds between 400 and 800 kilometers per second. When that wind happens to point directly at Earth, our magnetic field becomes the target of a continuous storm of subatomic bullets. On satellite images, coronal holes appear as vast dark patches, a contrast to the glowing seas around them. The one that opened in October 2025 was not only wide, but stretched across the sun's equator, a formation scientists call transequatorial. It connected both hemispheres of the sun's magnetic system, effectively forming a superhighway for solar particles to reach the planets. The Solar Dynamics Observatory's AIA instruments recorded this event in detail. Magnetic maps showed the field polarity as negative and fully open, an uncommon configuration outside of solar minimum. In simple terms, the sun had created an exhaust vent that faced Earth almost directly. Dr. Tomasa Skov, a leading heliophysicist, described it as a magnetic vent releasing the sun's breath. Her team observed solar wind streams clocking over 700 kilometers per second, each particle carrying energy capable of altering Earth's upper atmosphere. When these streams collide with the magnetosphere, they compress it like an invisible fist pressing against a shield of air. This interaction, what physicists call magnetic reconnection, is the real drama behind space weather. The interplanetary magnetic field, or IMF, acts as the key. When the IMF points south and Earth's magnetic field points north, the two can lock together. That moment opens a pathway for solar energy to flow straight into the magnetosphere, triggering everything from satellite drag and radio blackouts to brilliant auroral displays. And that's what happened in early October. The perfect coupling between the solar and terrestrial fields created a condition where even moderate solar wind became a powerful force. Electrical grids sensed fluctuations. Aurora forecasts spiked. The night sky over North America erupted in silent fire, reaching latitudes that hadn't seen auroras in decades. But behind the spectacle was something far stranger. The sun's open magnetic gate had aligned with Earth's shield, just as 3I Atlas disappeared behind the solar disk. For many, it was nothing more than timing. For others, it was the start of a cosmic coincidence too precise to ignore. The sun was venting plasma, Earth was bracing for impact, and somewhere between them, a frozen interstellar traveler was passing through the light. 3I Atlas is not just another comet, it's an interstellar messenger. The third confirmed visitor from beyond our solar system, following Oumuamua in 2017 and Borisov in 2019. But unlike those fleeting wanderers, Atlas behaves in ways no one fully predicted. Its composition, activity, and path through the sun's domain all hint at something foreign, an object forged under a different star carrying chemistry we've never seen up close. Ordinary comets in our solar system are dominated by water vapor, releasing familiar clouds of ice and dust when sunlight heats their surfaces. But 3I Atlas is different. Its coma is powered primarily by carbon dioxide, outgassing at rates nearly 8 times higher than water. That single fact stunned astronomers. It meant the materials binding this comet were colder, older, and likely formed in regions far beyond Neptune, perhaps even in the frozen outskirts of another solar system entirely. Spectroscopic observations revealed more clues. Even though its nucleus measured less than a kilometer across, it released up to 4 kilograms of gas and dust every second, creating a delicate shroud visible millions of kilometers away. But unlike typical comets, 3I Atlas didn't trail a long, glowing tail. Instead, it shed heavier dust particles, forming a faint asymmetric haze. Its rotation period, just over 16 hours, gave it a restless, tumbling motion, like a stone skipping through sunlight. And within that motion lay a deeper puzzle. The high carbon dioxide to water ratio suggested a surface rich in organic compounds, something almost unknown among comets that have visited our neighborhood before. As one mission scientist put it, this isn't a visitor, it's a chemical time capsule. When 3I Atlas approached perihelion, its closest point to the sun, scientists braced for volatility. Interstellar objects rarely survive such encounters intact. Some fragment violently under solar radiation, while others fall silent, their volatile ices spent. The question was, which fate awaited Atlas? Then, as the solar storm surged, 3I Atlas slipped behind the sun and was gone. For weeks, no telescope could see it. Spacecraft like SOHO and Stereo continued to collect data, but the comet's path lay within the sun's glare, unreachable. In that silence, speculation thrived. Had it fragmented, disintegrated completely, or was it simply dormant, waiting to emerge on the far side? 4 possible outcomes circulated among scientists. The first, survival. Atlas would reappear, dim but steady, following its predicted brightness curve. The second, fragmentation. Spacecraft would detect a sudden surge in brightness or multiple nuclei trailing along its orbit. The third, dormancy. The comet would emerge faint, nearly invisible, its activity collapsed, and the final, most dramatic, disintegration. No trace at all, only a fading dust trail where a comet once was. Each scenario had a distinct fingerprint, a sodium flare, a chain of fragments, a sudden dimming. But until the comet emerged from behind the sun, all anyone could do was wait. For scientists, 3i Atlas represented more than a fleeting rock. It was a test of cosmic chemistry under extreme conditions. For dreamers, it was a story of contact between two suns, one ancient, one alive, their energies meeting for the briefest of moments. And as the solar wind continued to roar toward Earth, some began to wonder, did the interstellar object trigger something within our star, or did it simply arrive at the wrong time? In the same week 3i in the Atlas disappeared behind the sun, a wave of powerful earthquakes swept across the Pacific Rim. Seismographs in Japan, Chile, and Alaska lit up within hours of one another, each registering magnitudes above 7. To some, it felt like the planet itself was echoing the sun's unrest. Could solar storms somehow stir the Earth beneath our feet? The idea isn't new. For decades, researchers have searched for links between space weather and seismic activity. The logic seems intuitive. If solar energy can disrupt satellites and power grids, why not tectonic plates? But the evidence tells a quieter story. According to the NOAA's Space Weather Prediction Center, Earth experiences an average of 15 magnitude 7 or higher earthquakes every year. Statistically, this week's activity fell right within that pattern. To geophysicists, coincidence remains the simplest explanation. There's no verified mechanism by which charged solar particles could influence deep crustal movement. Still, not everyone is convinced. Some independent researchers propose subtler forms of interaction. One theory involves ionospheric coupling, the idea that strong solar storms alter the upper atmosphere's electrical conductivity, slightly changing how the planet's rotation distributes stress along fault lines. Others suggest fluctuations in Earth's magnetic field could influence the piezoelectric properties of rocks near tectonic boundaries. Yet, despite years of data, none of these claims have passed scientific scrutiny. As NOAA forecaster Michael Foreman stated, extraordinary claims require extraordinary proof. Until then, a coincidence is just that. And yet, the timing remained haunting. A geomagnetic storm raging above, the ground trembling below, and between them, the silence of an unseen interstellar comet. The debate over cause and coincidence reflects something deeper, how science deals with the unknown. The sun and Earth are part of one magnetic ecosystem, connected by lines of invisible energy. But proving that connection requires more than poetic symmetry. It requires reproducible data, and so far, the numbers have not spoken clearly. In the end, the question isn't whether we want the universe to be connected. It's whether we can measure that connection, and for now, the instruments say no. Yet even among skeptics, one truth remains. 3i Atlas entered this story at the perfect cosmic moment, just as the sun was opening its magnetic gates and Earth was bracing for a storm. Whether by chance or pattern, the alignment feels almost choreographed, as if nature had timed its music to a rhythm too vast for us to hear. The stage is set. The sun is still breathing fire, telescopes are waiting, and the countdown to 3i Atlas's reappearance has begun. The world's observatories are holding their breath. On the far side of the sun, 3i Atlas should soon emerge, if it survived. Every 12 minutes, a new image from SOHO's LASCO C3 coronagraph flashes onto NASA's archive. Somewhere among the pixels, a faint point of light may appear, the comet's rebirth, or its final ghost. Around the globe, professional astronomers and amateurs alike join the search. Automated sky surveys, Pan-STARRS in Hawaii, the Zwicky Transient Facility in California, scan enormous fields of stars, comparing fresh frames with catalogs pixel by pixel. Any flicker, any motion out of sync with the heavens could be it, and when a possible detection appears, telescopes everywhere turn their eyes to the same patch of sky, confirming brightness, color, and movement. If 3i Atlas reappears steady and intact, it will mean survival, a triumph against the furnace of the sun. If its light flickers or splits into a chain of points, fragmentation. And if it remains absent altogether, it means something rarer still, total disintegration. No fragments, no debris cloud, only the faint trace of dust drifting through the void, a whisper of what once was. Yet the story doesn't end there. Even as astronomers wait for the verdict, another visitor rises in the dawn sky, Comet C 2025 A6 Lemon, gliding through the constellation Cancer, just visible above the eastern horizon before sunrise. To the naked eye, it's a pale blur, Through binoculars, a soft, round glow with a faint tail, easy to miss unless you know exactly where to look. But for those who find it, it's a reminder that the universe is never still. These moments of watching, waiting, searching are what connect all who look up. Each comet, each flare, each solar storm is a reminder that we live inside a system of constant motion and invisible threads of energy. The sun breathes, Earth responds, and beyond both, objects from other stars drift silently through, carrying the chemistry of other worlds. In the coming years, we'll see more of these travelers. Some will survive, some will burn away. Each will add a line to the grand experiment that is our understanding of the cosmos. For now, all we can do is look east before dawn, scan the horizon, and remember that every faint glow in the sky could be a message from somewhere beyond. This is Lumora, where science meets mystery. The story of Three Eye Atlas may be ending, but the sky's calendar is only just beginning to turn its next page.